But the marine part of it is actually... Yeah, I'm sorry, I can't be upstaged. Is it the one over there? How about we try it this way? Services provided by the ocean, so that whether they're ecological services like filtering nutrients and pollutants or providing habitat and food for animals within the ecosystem, it's habitat, it's breeding grounds, it's also the world comes out of the ocean, and every second breath that produced from phytoplankton. On the human side of things, we already recognise there's lots of food.
security, longevity. Never have so many had so much. Yet 1 billion are malnourished. In a single lifetime, we have grown into a phenomenal global force. We move more sediment and rock annually than all natural processes, such as erosion and rivers. We manage 3/4 of all land outside the ice sheets. Greenhouse gas levels this high have not been seen for over 1 million years. Temperatures are increasing. We have made a hole in the ozone layer. We are losing biodiversity. Many of the world's deltas are sinking due to damming, mining, and other causes. Sea level is rising. Ocean acidification is a real threat. We are altering Earth's natural cycles. We have entered the Anthropocene, a new geological epoch dominated by humanity. Present. We present shape our, we present shape our, we present shape our, we present shape our.
got the human side of things to do, but it's likely to be by a metre. So that doesn't sound awfully like light. Like my kids go, oh, we can cope with a metre, it's only that much. But it actually means that some of the biggest megacities in the world have serious problems with regard to inundation, salt intrusion into their water. You know, there's quite a large large percentage of the world's population that could be affected. And if we go really for the high end of things, then, you know, something like a third of Bangladesh is underwater in most island nations. In fact, we've had the first island in the world abandoned because of sea level rise already north of Australia. So it's a process that's already underway. Ocean acidification is something else that's happening. So as you get carbon dioxide in the atmosphere, by pure chemical interaction, it gets drawn down into the ocean. Solubility, it's called. And then you've got the phytoplankton that uptake it and they settle out. So you get the drawdown of carbon into the ocean, making it more acidic. Unfortunately, with temperature increases, the chemical part of that doesn't work as well. And also, which means that also the acidification in the ocean itself means the phytoplankton part doesn't work as well. So more and more of the carbon ends up back in the atmosphere, increasing the temperature effect. So it's the feedbacks and how they change through time that are extra process indicators that we have to get our head around. So this one doesn't have any sound, so hopefully we can... Just to give you an idea of the level of acidification that we're looking at, starting in 1950, running forward to about now. So this is now going even further. You can see pretty much the whole ocean is changing its pH quite substantially. Parts in the poles are becoming quite extremely changed. But by about 2200, we've pretty much made the whole world. They've picked this to be quite a delightful colour palette, but, you know, quite a bright and big change. So that's, given it's a log scale, that's a significant change on the little animals that have to live inside of that, which has implications for things that have shells that are external. So forams, for instance, already starting to see some degraded shells. Lots of the other animals that have membranes or coping mechanisms won't suddenly fall off. You still have lobsters and things like that, but they'll be under higher stress. Some of the more interesting things are around vertebrate behaviour. So it affects the chemistry of the brain, so they try to breed with the wrong things, like their parents instead of non-kin. They're attracted to the wrong places, they don't go to where their habitat is, they forget to avoid predators, they forget how to hunt prey. So there will obviously be some acclimation and adaptation around that, but there's some deep, wired parts of the brain and the physiology across all species that will be really stressed in those kind of environments. There's other things that are just coming onto the radar, such as stratification of the world's oceans. As it becomes warmer, it'll become more layered, which means it's harder in some locations to get nutrient mixing, and so production changes. In other places, it'll change where the mixed layer depth is. So it'll fundamentally shift where the fluxes and things like that happen in the ocean, where the production regimes are, which doesn't sound too bad if you're in a global economy and can share that food around. But if you end up a bit disjointed and you're under pressure, you know, you can imagine to say, if Australia suddenly ran out of food, it might say, well, I'm keeping any fish that I catch now for me. I'm not going to share it with you. If you're in a tropical location where your fish production's dropped, that's going to have a serious problem for you. The next part of it is hypoxia. So there's two main ways that the hypoxia in the ocean is starting to affect the world. So one is through nutrient runoff from the land, so that land-sea interaction coming in again. If there's high nutrients, it starts to become anoxic at the bottom, the bacteria take over, and it's a dead zone. So much of the Gulf of Mexico is already a dead zone because of the nutrients and pollution that comes down the Mississippi. The other mechanism that's starting to happen is that just naturally a lot of the deep ocean is low oxygen, and as the winds strengthen at the surface, that strengthens upwellings and sucks those low oxygen waters to the surface, and that's already starting to be seen off the coast of California. That has implications for fish production, but also for squeezing all the animals that are in the top half of the water column up to the surface, so that it changes the interactions of predators and prey, and particularly mesopelagics. By sort of 2100, you can see that there'll be quite large changes in ocean oxygen in different parts of the world as that 200 to 600 metre level. So it's again changing where things are and how they interact. So it's going to change how we interact with the ocean as well. And that is reflected in primary production. So There is a fertilisation effect of carbon and temperature on phytoplankton. In some regions there'll be an increase in production, quite large potential increases. But pretty much across this middle area there's going to be a decrease, or at least that we think so far. And that's reflected also in fish catches and biodiversity turnover. So species turnover, start to not see too many species get added to the tropics, and some actually probably will leave. But you get a change in the fish catches, so you start to get a decrease. And I don't know if you've seen a pattern here, but over and over again, the bad effects are happening through the middle here, and the good effects are happening up the top, which is kind of ironic given it's the people up here that have done most of the emitting, and the people down here are just starting to get growth. So the people with the least capacity, with the most growth yet to come, are those seeing the biggest effects. So it's kind of it's an unequal distribution of effect, and so that has implications for conflict and other things going forward. On the ecosystem side of things, there's quite strong change possible, like regime shifts. This is a bit of a cartoon of a potential regime shift off Australia, where the current very demersal mesopelagic ecosystem shifts to one that is run on small flagellates and jellyfish and small pelagics. It doesn't mean that there can't be sustainable fisheries in Australia under those conditions. It just has to be that we need to be fleet of foot in keeping up with that. We have to use indicators to tell us not only where we are now, but where we're going, so that we can adjust our management accordingly. So there's quite a lot of effects that are already happening from climate change that are feeding back to people and being noticeable. And these have quite a large number of effects. So there's many pathways that are quite hard to summarise in a simple diagram. But basically it comes down to the availability to grow food changes. In some places we've hit the photosynthetic potential of plants. We can't get any more out of plants. There's displacement and conflict that comes along with these kind of effects. Malnutrition and poverty. So all of that affects the labour. So there's a business in the world today whose only job is to go around and tell other businesses how safe it is to invest in that country. What's the risk that your labour force can't come to work because they're too poor or too sick or too hot, or the chance of war. So there's other industries that are cropping up to try and deal with the pressures we're already seeing from climate change. It's also a shift in the distribution of the people. So these are coastal areas that are already impacted by humans. So some of those are from nutrient runoff and even tourism, where we've cleared mangroves to build artificial beaches and things like that. But one of the clear things is that coastal populations rely a lot on the ocean, can be the major GDP for some countries, and that's actually where most of the human population is going to be added. So in the developed world, we're just not growing very much, so we're not going to see very many more large cities along the coastline. But in the developing world, there's a very strong growth, so that globally, as much as 75% of the population is going to live along the coastline, exactly where all of these marine ecosystem effects are going to be seen by 2050. Now in Australia, we already have that situation. More than 75 to 80% of Australia's population lives in a thin band along the coasts. And so I can tell you already, it's a very crowded space. So most of the production happens along the coast, but it's also where most of our shipping, our fisheries, our energy is produced as well. That means there's a lot of management in that area. So there's lots of competing pressures on this one little space. So that is something that you need good information to help support. And our problem is dwarfed by the kinds of challenges that would be faced in a place like China. So this is a beach in China. As an Australian, that's a lot of people. I can regularly go to a beach in Tasmania or up in northwestern Australia where I'm the only person on the beach. So for me to see that kind of thing, it's like, wow, how do you even get to the water? So, but they're really going to be facing a lot of challenges moving forward. And that's an issue because management hasn't been fixed. So this is the Steel of Hammurabi. It was written about nearly 4,000 years ago. And on that steel, he was laying down the laws for his civilization in the Middle East. He said, what do I do about overfishing? There's fishermen who are exceeding their catch, who are destroying their ecosystem. What do I do about it? His son's solution was to behead them. That's not going to work so much these days. But it is something that's persisted through time. Emperor Claudius actually did species translocation to try and solve overfishing in the Mediterranean 2,000 years ago. He got the entire Roman fleet to carry parrotfish from the Black Sea back to Italy and then banned fishing on Italy so that his favourite parrotfish could be reintroduced. It has succeeded, it's still there today, but it's the kind of scale that you're not going to see anymore. But it has been the topic of much discussion by very powerful people, including popes. It's why they relaxed some of the rules about what was fish through the medieval period and into the later part of that for Fridays, because there just wasn't enough fish to eat along the coast of the Mediterranean. So it has been a topic that's been of big question for a long time. We're starting to realise today that one of the problems that they'd forgotten about was it's the indicators of the human parts of the system, not just the natural parts of the system, that they needed to be following. You've got to get a good trade-off between the social, the economic and the ecological to get a complete picture of what's going on. And so that's why the rest of this week we're going to be looking at all the different parts of the system, not just the environment. If you've got just the environment, you haven't got the whole story. Cool, there you go.